The units for wavelength is meters, or it could be in any length. It could be centimeters, it could be micrometer. And frequency is in the units of per time. So it could be per second, it could be per minute, it could be per hour, but the most frequent one is per second, which is hertz. So hertz is just basically 1 over s, or 1 over second. And if you do a dimensional analysis on this, c is meter per second, while lambda is meter. So you can cancel meter and meter, and then you get per second, and per second is hertz. Now the frequencies or wavelengths of the radiation is continuous, so it's not one particular frequency or one particular wavelength is there. Like for example, you have a range, and then there is one say is a range, and then maybe 1 meter, and then 2 meters, and so on. And you imagine it to be where you have one type of wave, and then you have another type of wave, and maybe another wave at 3 meters, for example. So the spectrum of radiation is not discrete. Discrete is spelled like that, which means that they are separated. They're not just one by one. They're continuous. So it looks something like that. Continuous. So that means that every point of the spectrum, there is a certain wavelength that spans the entire spectrum in a continuous manner instead of a discrete manner. So when you look at that description, it says that the frequencies of wavelengths or wavelengths of the radiation from the sun or light or electromagnetic radiation is continuous. So in atmospheric science, the wavelengths are separated to two, just to simplify the types of radiation there is in atmospheric science. To simplify it, we separate it into two categories. One is the shortwave radiation, and there's also the long-wave radiation. Have you heard of shortwave and long-wave radiation before? So there is a cutoff point at 4 micrometer wavelength. Lambda is 4 micrometer. Anything that's less than 4 micrometer, we call it the shortwave radiation. And anything more than 4 micrometer, we call it the long-wave radiation. Now, mostly, if it's shortwave, less than 4 micrometer, the radiation comes from the sun. And anything more than 4 micrometer, the radiation comes from the earth. Now, it doesn't have to be light. Light is something that we see. It's called the visible light. But then it's only a narrow range of the spectrum. Maybe this is the entire spectrum, and what we see is just this range. But there's all these other ranges, right? So at 4 micrometer, what we see is this one. Anything that's here is from the sun, and part of it we see from the sun. And then there's also the long wave radiation where we don't see, but it's still there. And this radiation comes from the earth or from other things besides the sun. Like even any surface that sees radiation from light, like say this floor, it just emits some radiation, but at a frequency or wavelength that we don't see. And that's a long wave radiation. So another term is this monochromatic term. Mono means one. Chrome is another word for color. So one color. Monochromatic denotes a specific frequency or wavelength, because in this radiation spectrum, a certain wavelength, like say here, corresponds to a certain color. But that, when I say color, because that's what we see. Where the blue color is of a certain wavelength, the red color is another wavelength. So when they mention monochromatic, means that a certain color, and that certain color means that it is of a certain frequency or wavelength. You saw this sketch just now. So this is the actual spectrum, but then they don't show the actual values. It goes from 0.01 micrometer up to 10 to the power of 5 micrometer, or 10 centimeters. Now anything below or around 0.01 micrometer, there is the X-ray radiation, and a bit above that is the ultraviolet radiation.
So after the ultraviolet radiation of about 0.39 micrometer, then the visible light radiation begins until a narrow range, and it is only for a narrow range until 0.76 micrometer, where it goes into the near infrared radiation. And from there, it goes to infrared and up to microwave, which is a very large um, wavelength radiation group. Also, recall that photosynthesis uses a narrow range of radiation within of 0.4 until 0.7 micrometer, which is the same as the visible light radiation.